Hello everyone and welcome to Logistic Regression. Just like in linear regression, we use logistic regression to predict the outcome of variables based on the value of other variables. You use logistic regression rather than linear regression when you're trying to determine the probability of a specific event. Logistic regression is widely used in higher education because we're often concerned about dichotomous outcomes. And dichotomous just means that there are two available values. Like, how do certain factors affect whether or not we retain students? Retained or not retained? What factors affect whether or not they graduate? Will alumni make a donation or not? But it doesn't make sense to use it for just any dichotomous variable. It makes sense to use when the nominal variables are free to vary. As an example, it probably wouldn't make sense to use high school GPA, SAT scores, and class rank to predict the probability of someone being male or female, though you could. But it might make sense to use them to determine the probability a student will graduate. The outcome variables should be nominal and have only two possible values. The predictor variables may be nominal, interval, or continuous, but in most cases, it's either interval or continuous. So why not just use a t-test or ANOVA? We've already been through that, right? Well, this is where it gets a little tricky. The best example I found is in the discussion on this web page here. Let's say you're a researcher who's interested in whether or not cholesterol is associated with heart attacks. You could do a t-test to compare cholesterol levels between women who had heart attacks and women who didn't, and you'd be able to tell that cholesterol is related to heart attacks. But if you use logistic regression, you can predict the probability that someone with a particular cholesterol level will have a heart attack, and give them advice like, if you reduce your cholesterol by 20 points, you'll reduce your risk of heart attack by X%. In logistic regression, the null hypothesis is that the probability of a particular value of the nominal, or y variable, is not associated with the value of the measurement, or x variable. In other words, the slope of the line describing the relationship between the two variables has a slope of 0. So let's look at the equation so you can see that. To test the null hypothesis, logistic regression calculates something called the logit, or the natural logarithm of the odds of y, the outcome variable. In this equation, pi equals the probability that y will occur. So you're taking the natural log of the probability divided by 1 minus the probability, and this is called the odds ratio. If you have the multiple predictor variables, the equation looks like the second one, but we'll stick with that first one right now. In that equation, the beta coefficient is the important one. By taking the exponent of that value, you get the odds. So if you were predicting retention by male-female and you got a beta coefficient of 0.223, you could take the exponent of 0.223 and get 1.25, and that would mean that female students are 1.25 times more likely to be retained than males. Just an example, not based on real data, guys. The last part of that equation should look a lot like linear regression, and it is. This is why we use the natural log of the odds. The relationship of the probability between y and x is nonlinear. In fact, it generally looks like this. In linear regression, the results of the analysis can be plotted as a straight line. The results of a logistic regression analysis can be plotted as what's called a sigmoidal curve, basically an S-curve. You can see that all the values fall between 0 and 1 and are concentrated at both ends. In logistic regression, you use the maximum likelihood method rather than the least squares method that you use in linear regression. There are multiple methods of estimating the p or probability value. One is called the walled chi-square method, but it may be inaccurate if your sample size is small. Another is the likelihood ratio method, and they can produce very different results. Just like in any other test that we're doing, there are assumptions that you have to make when using logistic regression. First is that the test observations are independent of one another. Second, the outcome variable must be mutually exclusive. You can't be retained and not retained, for example. The third is that there is a linear relationship between the natural log of the odds ratio and the measurement variable. Another way of saying this is that the same probability is maintained across the range of predictor variables. However, logistic regression does not assume that the measurement variable is normally distributed. So let's recap. Use ANOVA or t-tests when you're trying to compare means. Use linear regression when you're trying to predict the probability of a measurement variable like GPA, and use logistic regression when you're trying to predict the probability of a particular outcome, like whether or not a student will graduate. I found these resources helpful when developing this presentation, and those first two especially are really simple explanations of both simple and multiple logistic regression. Thank you.